In this short video recording, we're going to take a look at some tools found inside a Carlson survey and Carlson Civil that will allow us to take graphically collected RTK GPS data and use it as inputs for a roadway redesign project for US Highway 52 located in northeastern Iowa. To start, I'm going to launch into the Carlson 2017 environment, and we have some data that's been generated on the screen through our field to finish routine. And what I'd like to do is to isolate the centerline shots for this roadway corridor project. To do that, I'm going to go to my View menu. I'm going to say Isolate Layers. And I'm going to select then one of the points on my screen. And that will then limit me to the data of just my centerline shots. And as I take a look at this entire reach of data, one of the things I'd like to do then is to put a best fit center line through these data points. To do that, I'm going to go into my Carlson survey menus. And underneath Carlson and COGO, we're going to say best fit and best fit center line. And I'm going to then use points on the screen, so I'll press enter for that. We will grab our points from the screen itself, and I'm going to choose all the screen entities that I have, but I also want to remove 2 points from consideration. So I'm going to hit R for remove, and then I'm going to remove point number 2068, and then I'm also going to remove point number 100. And as I remove that data set, then my updated count of 68 entities is now presented to me, and we'll go ahead then and for the best fit centerline itself, we're going to put this resulting graphical polyline on a survey road center B fit for best fit, and then I can indicate the snap tolerance and maximum radius for any curves that it might find. So we're going to go ahead then study and perform a mathematical regression through the data, and then provide the results of that analysis on the screen for further consideration. So as we take a look at the data in here, then I can sort of scroll down and find if there's any kind of outliers that I might want to remove from the processing. So as I'm taking a look at this, I've got a pretty good jump here in 2 of these. So I'm going to process and turn the processing for this first shot off. We'll go ahead and recompute the information. And then as we take a look at this, we will see if there's anything else that we might want to turn off. And as we roll down through here, let's take a look. So yeah, again, here's another sort of heavy outlier. So I'm going to go ahead and turn the processing of that one off. So the best fit centerline routine allows me to then control the kinds of data that I am using to create my best fit centerline. And once I'm happy with, for example, maybe the average residual, I'm just going to go ahead and choose OK. And the result then is a polyline on the screen that is the best fit center line for my roadway data. So now that I have that, what I'm going to do is take and turn that polyline into a Carlson centerline file. I do that through my centerline menu, and I can say polyline to centerline file, and I'll just call this maybe my Highway 52 centerline. And we choose then the polyline that represents that center line, which we'll grab on the screen here. And you can see it's increasing its station direction to the south. So I'm going to choose R for reverse to reverse that direction. And I'll just give it an arbitrary starting station of 0 plus 0, 0. And now that it's been turned into a center line, what I can do is double click on it. And you can see now I have edit data of consisting of lines and curves that is the best fit result of my field survey data. So now that I've turned this into a centerline, what I want to do is take a look at maybe the design profile information or the existing ground profile information. And to do this, I'm going to switch into my civil menus. So I'm going to go Settings, Carlson menus, and we'll choose the civil group. And underneath the Profiles menu, I'm going to say Create Profile from a Grid or Triangulation Surface. The surface model I want to process is the Highway 52 Iowa merged tin. So I'm going to go ahead and open that up. And I'm going to link the profile I'm going to be generating here in just a moment to the surface model. And if the surface model changes, I will be prompted whether or not I want to actually update the profile data. And this is going to be a roadway centerline, so I'm just going to go ahead and choose OK. And I'll call this my Highway 52-existing for existing ground profile. I'm going to choose the C for centerline option here to actually go out and get my centerline data. And it's then generated a profile. If I want to take a look at that profile, I'm just going to go to my Profiles menu and say input edit profile file. And here is my profile that it found. We can go ahead and open that up, and we can see that it actually contains then data points throughout the entire length of that corridor shot. Now that we've generated an existing ground profile, maybe we want to take a look at one of two different scenarios for how to produce maybe a design profile information. The first one we'll take a look at is found again underneath the Profiles menu, and underneath Profile Utilities, we're going to choose the Best Fit Profile. So for Best Fit Profile, we're going to create a brand new name. So maybe we'll call this Highway 52-BFit as my new profile name. Actually, take that back. We are going to process the existing ground profile data. We want to take a look at all this information and put a best fit through it. So we'll open this up, and we can again choose the kinds of values for the minimum vertical curve lengths, the minimum distance between vertical curves, and we'll go ahead and choose, this is actually a milling profile, we'll just go ahead and choose OK. And again, I can take a look at all this information with the residuals that are in here and find out again, is there any outliers in here that we might need to take into consideration. So for right now, I'm just going to say this is probably all OK. Let's just go ahead and choose OK. And now we can say the name of the profile that we are generating is the Highway 52-BFit profile. And if we want to take a look at that now, we can go underneath my Profiles menu and say Input Edit Profile File. And again, we have the BFit profile in here. And it looks like we got one little anomaly up here at the top, so I'm going to take this first station range here and just remove that row. And then I'll also say, for reference purposes, let's take a look at the existing ground profile along with it, and we'll see how these two match up. And from what I can see in here, it looks very good and very clean. So I'm going to say, yeah, this is a good best fit profile for what I have. And as I go ahead and exit out of this, I'm going to say, yes, I'll save my changes here. Another type of a design profile we might want to take a look at is a roadway rehabilitation profile. So if I go underneath my roads menu and I take a look at the road rehab profile routine, again in here we can say we're going to output a rehabilitation profile, and the name of this that I want to use is going to be Highway 52, and I'll just say Rehab. And we're going to then process the center line that we've established, and we also want to build, in this case, a design template. So for the roadway reconstruction that I want to do, I'll go ahead and create maybe a rural type of template, and we will then go ahead and place this information on the screen. So the first thing I might want to do is put in a grade segment. So coming off the center line at maybe a -2% slope for a distance of, let's say, 14 feet to an edge of pavement code will be my first grade segment. I'll put in another grade segment, again, maybe now at a -4% slope for a distance of maybe 12 feet for shoulder. And now I have two grade segments in here. And now what I want to do is maybe place in some subgrade information. So I'll go ahead and click on the subgrade button. And starting at the horizontal offset value at 0 right at the center line, we're going to go ahead and say maybe we want a 6-inch thick material for a distance to the EP code. So rather than using a distance of actually, for example, 14 feet as I had gathered earlier, I'm just going to use the EP code to say that as my edge of pavement changes, the subgrade should change along with it. And maybe we'll put in a material called concrete in here. And then we'll go ahead and put in another one, another subgrade unit. And we are going to say at a horizontal offset of EP for, again, edge of pavement, maybe this time what we want is 4 inches of material. And we'll go to a distance defined by the shoulder code. And we'll call this maybe crushed ag. And what I have now are then two sets of materials, the concrete road and then the crushed aggregate shoulder. And then what also want to do is maybe put in some cut and fill slopes in here just to tie this roadway section back into the surface model I prepared earlier. So to do that, we'll just put in a quick 3-to-1 slope for a cut scenario and a 3-to-1 slope for a fill scenario. And what I can do now then is take a look at the next part of the road rehab option, which is to then say for the existing surface model, again, we're going to use the merged tin. And the result now will be an output of a road rehab profile that will then also be used for milling purposes. So we can say we have a minimum milling thickness of maybe 1/10, an overlay thickness of 1/2 foot, and we're going to process the edge of pavement and centerline codes for this rehab profile. And as again we go through and click on this, we can say we want stations maybe every 50 feet. We'll look at this, and actually let's change that down to every 25 feet, and we'll just say OK. And then the resulting best fit profile now from this data will be generated, and again we can process different stations on and off as we need to. So now that I've created another rehab profile, what this gives me the ability to do is to analyze the differences between the best fit profile that I had established versus the rehab profile. So if we want to take a look at the rehab profile, we can just go ahead and click on it, and we can see we've got some data in here, but for this case we'll just go ahead and use the best fit profile. So now that we have our profiles and centerlines and templates already established, the next step will be to go ahead and actually process the road. We can use that underneath the roads menu. We're going to say process road design, and you can see we already have a lot of the data already filled out. So we have the centerline established. We're going to choose, actually now in this case, maybe the best fit profile. The design template will be this rural. The existing surface model will be the merged tin. I can go ahead and put in other pieces of input information, but in this case, all else I want to do is to create some cross-section files. So I'm going to specify that I have a cross-section file. We'll call this Highway 52-finished. And we're going to also create a Highway 52 existing. As I have my processing values in place, I'm going to go ahead and just choose OK. I can indicate the stations of ranges, the station ranges to process. The interval we'll do every 100 feet along this particular project, getting cross-sections out to a 70-foot offset. And I can go ahead and indicate surface models of both the road and then the road with the existing ground. So I've got a Highway 52 road tin being specified along with a Highway 52 second merged site. And I'm going to go ahead and just choose OK. So we'll go ahead and process all this information now, giving end areas and their total volumes. We can go ahead and print this information out if we choose to. We'll just skip over that for right now. And then the result will be a process road redesign with the surface model files that we're going to write. So I'm going to go ahead and let's make this one a Highway 52 merged 2, and actually make this maybe a merged 3 just to have it as a separate one in here. So now that we have that triangulation file built, we can go ahead and take a look at the surface there. So we go to our view menu in our 3D viewer, and we'll take a look at our surface file. Let's go grab the merged 3 tin, and we'll open it up and we'll see what we got. So now this one's been colored in for me, and this makes it suitable for use inside of, for example, Carlson Precision 3D templates. And so far, I'm happy with the result. So if I want to take a look at the second surface model, merged 2, we'll go ahead and do a view on that. And again, we'll say we want to go to my 3D viewer menu, look at the surface file for the second merged tin. And this is now sort of the composite with also with the LiDAR surface model that we had built earlier. So now that I have my roadway designed, I can now take a look and create some cross-section sheets, which we'll do in a separate session. So that concludes this presentation on how to leverage some of the design tools found inside a Carlson survey with Carlson Civil for maybe some roadway reconstruction studies. Thank you for your time.